Mole ratio lab part 2, copper plus silver nitrate. And let's bring up a document for this. Sorry about that. Here we go. So this is the mole ratio lab part 2, and this is the document for that. And let's just get a better look in this. I think this will work. Get a little marker here so we can see. And in our last lab, just reviewing, we took, in part 1, we took iron plus copper chloride, and we formed copper solid plus iron chloride. So the iron replaced the copper being all by itself and essentially crystallizing out on the nails, and then the iron leaving the nails and going to an iron chloride solution. Notice that the ratio of moles of iron to moles of copper chloride to moles of copper to moles of Fe iron chloride is everything is 1 to 1 to 1 to 1. In this experiment, we are going to do another single replacement reaction, but instead of iron replacing copper, we have copper this time replacing silver. So copper will replace the silver, leaving silver by itself and forming copper nitrate. So we have copper solid. This is a formula for silver nitrate, which is a solution, so it's aqueous, forming silver, which is solid, and then forming copper nitrate. Notice the subscript here. Copper generally has a +2 charge, so nitrate is -1, so you need 2 of them to balance. This 2 doesn't mean there's 2 CUs. This 2 does mean there are 2 groups of NO3. Now, when you complete this, you have to put the right coefficients in front to balance this overall equation. And a hint would be, if this number is 2, what am I going to need to put in front? 2 here in order to get 2 nitrates. But I would also have 2 silvers, so you're going to have to make the adjustment over here. But I will leave that for you to complete. Okay, so day 3 of the experiment is we have a silver nitrate vial, which are just some crystals, and I'm trying to think of it, little white crystals in 1 gram. It's a very small amount. I don't know if you can see this, but it was the bottom of this vial. May or may not be able to see it. But there are just a few crystals at the bottom of this vial. So what we did was we weighed this vial before and after. The difference was the amount of silver nitrate. Okay, we took a copper wire and roughed it up, and we scuffed it up and we weighed it. And then what we did is we took the silver crystals and put it in a test tube that looked like this. And I stirred it around. Okay, I stirred it around. Okay, first I stirred it so all the silver nitrate dissolved. It's a clear solution. And then the last thing I did was I added my copper wire to it. And pretty immediately you start to see a reaction. Now, really this is water, so you won't see a reaction here, but the silver nitrate looks the same. And you'd start seeing that crystallizing out probably even a little bit right now. So that is the reaction that we looked at. Now, ultimately, when we came back the next day, we started seeing this grow. We saw something like this. Okay, so we got this blue solution, which is really the, I better slide this up to see this better. Scroll, whoops, scroll back up. And see in the wrong spot. Okay, so just looking at this, we have this blue solution, which is copper nitrate right here. And then we have on the copper wire are crystals of silver. So that's what we set up, and then overnight that reacted, and that was what we'll call the day 3 reaction. Now, what did we do on day 4? we just wash these crystals. So essentially, we jiggled this, it got most of the silver off, we power squirted the silver off, and we put all the silver in a beaker, decanted off the blue stuff, and then we washed it once and chomped around to get rid of the impurities, decanted, and then we repeated with 2 more washings. So instead of silver with some copper nitrate on it, we end up with just silver. Okay, and then finally, on the last day, we let it dry overnight, or actually over the weekend, and then we will weigh our silver. And after we wash it, it might look something like this. Okay, you can see little silvers in there, and then we're going to let that dry out before weighing it, so we get rid of all that water mass. And that's essentially the experiment that we did. Very similar to the first reaction of iron nails and copper chloride, but this time we had copper and silver nitrate forming silver on the wire and then getting the copper nitrate solution, that characteristic blue for copper solutions. Okay, so let's look at some data that you have. So you can certainly describe these observations you've seen in this video. There is also a time-lapse video. It's about a 1-minute video showing this reaction, kind of going through a process. And I would watch that. It's just a short clip. You can see it better. Okay, so I weighed my empty beaker and then the mass of the beaker in silver crystals at the end of the experiment. So this would be after everything was done, and you can get the amount of silver there, and then you can convert that to moles. Okay, we kept the silver nitrate in this vial. We weigh it before, we weigh it after. We found out that the difference in grams, and then we can convert that to moles for silver nitrate. And let's see, am I missing something here? Oh, the copper wire. We weighed the copper wire before the reaction. We weighed it after because it lost some mass, and we can figure out the mass consumed, and we can convert that to moles. Remember your sig figs when working with converting your grams and your moles and including proper units. And then there are a number of mole ratios that we have to figure out. Okay, looking at the balance equation, once you get it balanced, you should figure out the ideal ratios. Okay, by knowing these coefficients in front. And then we're comparing it to what we actually recorded in the lab, and we will report our decimals to the right number of significant figures. Okay, so just like we did in the first part of the lab. Okay, so I look at that, and there's a percent error calculation, a couple other mole ratios we're supposed to be calculating, and then just some questions involving mole train problems based on amounts in your lab. So those are some questions there. In our conclusion, our main focus will be on the ratio of silver to copper, the moles of silver to copper. And we ran a percent error analysis on that. Remember, link cause and effect when you're doing that. And it says talk about any major errors with the other mole ratios. So even though we're focusing on copper to silver, we also want to consider copper to silver nitrate and silver to silver nitrate ratios as well. And then just what's happening at the molecular level. So it is parallel to the first lab you did. And there was extensive videos on that, except we see the differences and you have some data with which you can work if you were absent for all parts of this lab. All right, good luck. Let me know if you have questions. Thank you.